Imagine a brain, not made of biology, but of mathematics. This is a neural network. Just like neurons in your head, these artificial nodes are connected in layers. Information flows through them. Input enters, passes through hidden layers, and produces an output. But this isn't magic. It lives here, on massive servers processing billions of calculations per second. At first, the machine guesses. It might see a cat and think it's a toaster. But through backpropagation, it checks the answer, realizes the error, and adjusts its internal connections. Until finally, the patterns match. It sees the world as it is. This ability to see wasn't built in a day. In the 1950s, scientists sketched these ideas on paper, trying to mimic the biological synapse. But they lacked the raw power. It took decades for hardware to catch up with the theory. Today, those massive servers we just saw don't just store data. They process it using GPUs capable of parallel thinking. But raw computing power is not intelligence. Without direction, this massive flow of data is just noise. To learn, the system needs to filter the signal. It needs to decide what matters and what to ignore. Think of the network as a giant mixing desk in a music studio. We need to tune the signal. Inside the code, we have weights, a virtual knob that controls how important a piece of information is, and biases, a threshold slider that decides if a neuron should fire a message forward. When we saw the machine correct the toaster mistake, it was actually tweaking these billions of tiny knobs simultaneously. The goal is harmony, but when we first turned the machine on, the music is chaos. In the beginning, the knobs are random. The network is screaming in confusion. The error rate is high. Mathematicians call this the loss function. Our job is to cool this system down. With every example it learns, it nudges the weights, finding the path of least resistance. The noise fades, the signal becomes clear. From chaos, we create logic. Now stable, the network can start to see, but not like you and me. It reconstructs reality layer by layer. The first layer only sees raw edges and contrast. The next layer combines these edges. Suddenly, a curve appears, a shape, a texture. Deeper layers find complex features, an eye, a nose, a whisker, until the final layer recognizes the full picture, the cat. We are building a mirror of our own intelligence. It learns from our data, our art, and our mistakes. As the layers get deeper, the line between code and consciousness gets thinner. Welcome to the neural age,